All right, it is Friday. You're watching this video, which means you are already in the session 3 folder. But just to revisit how we're navigating this course, I'm going to shift over so I can see Friday's agenda for math. And I can see that the topic is algebraic expressions, so I know that's the folder I'm looking for, that I need to do all of the items in the folder, and that what is due is the quick check. So in this video, we'll actually do a lot of it together. And I will also let you know what you need to do on your own from there. So I'm going to go into the folder. And when we talk about algebraic expression, it has a lot to do with letters. When you learned to read, you learned about the important relationship between letters and sounds. Letters are also important in math as they can be used in expressions. In this lesson, you will learn how to use letters to represent unknown values in mathematical expressions. So I'm going to walk through this following activity where we'll be sorting expressions into 2 groups. Then we'll be thinking about how using a letter changes an expression. So let's click on this link. And if you'd like to go back and do this on your own, you can. Okay. So this says sort the 5 tiles into 2 groups. Describe each group. Then sort the 5 tiles into 2 groups again, but in a different way. So the first way I'm going to sort these is by expressions that use a letter and expressions that don't. Okay, so we'll be talking about this later, but each of the items on this side, um, on the right side, are using only numbers. Those on the left are using a letter, a variable. So let me reset these and sort them in a different way and see if you can figure out how I've sorted them this time. What do you think? Think about it for a minute. What do you notice that all of those on the left have in common and all of those on the right? Okay, so in this case, I have a mix of numerical expressions and expressions with letters on the left side. I sorted this way by sorting those that use either addition and subtraction on the left and the one that uses multiplication on the right. Okay, so we examined expressions that contain numbers, operation symbols like addition, subtraction, multiplication, division, and in some instances, a letter. So this is what we want to be thinking about. What does a variable allow you to do that you couldn't do before? So we're going to talk more about this. Okay. You do not have to do this piece, the student companion, but you may if you'd like some additional practice. And then feel free to read through the objectives and the keywords: algebraic expression, evaluate, numerical expression, and variable. It could even be a good idea to take a minute and write these down as their keywords. And as we go through the lesson and you learn definitions or examples, you can add those to your notes. So our objectives, our goals are to differentiate between a numerical and algebraic expression and evaluate algebraic expressions for the given quantity. So let's keep going. We'll see a little bit more what that looks like. Okay, so what is an algebraic expression? So far in this course, you've been working with numerical expressions, which are expressions that consist of numbers and at least one operation symbol. As a reminder, operation symbols are the symbols that represent addition, subtraction, multiplication, and division. So this is just an example of a numerical expression. 4 times 6 divided by 3 plus 19. We have at least one operational symbol, and we have a series of numbers. There are times in math, though, when you may have an unknown amount in an expression. In these situations, you use a variable, which is a symbol that stands for the unknown amount. Letters are frequently used as variables. The letters X and Y are commonly used as variables. When solving word problems, the first letter of the unknown amount can be used as a variable. So let's look at this example. Greg has $25.53 in his savings account and wants to purchase a new book. How much money will Greg have left after he purchases the book? In this situation, you know that Greg has $25.53 in the account, but you don't know how much money the book will cost or how much money he will have left. So to represent the situation, you can write an algebraic expression, which is an expression that consists of numbers, at least one operation symbol, and the difference between this and a numerical expression is that it has at least one variable. So for example, $25.53 minus B. Here, B equals the cost of the book. That is our unknown amount. In the example below, identify the variable in the algebraic expression. So which of these items is the variable? The variable is the unknown amount, represented by a symbol, often a letter. So in this case, the variable is D. Let's check our answer and see if that's correct. The variable is D. All of the other values are numbers. Okay. You may go back and click on this link if you would like to watch the equivalent expressions tutorial. All right, let's look at a couple more examples. Now that we know what algebraic expressions are, we're going to talk about and practice evaluating them. How can you find the value of an algebraic expression? You can substitute a given value for the variable. So suppose from the last example that Greg's book cost $5.99. To find out how much money Greg will have left, evaluate $25.53 minus B, and we will put in the value of $5.99 for B. So we can rewrite the expression $25.53 minus $5.99. So we don't have to solve this here. We've been given the answer to evaluate that the answer is $19.54. So in this case, if the book costs $5.99, we put that in for B. That means he will have $19.54 left in his account. Okay, so now let's evaluate $25.53 minus B if B equals $7.34. Pause the video and solve that on your own. Once you have your answer, you can push play. Okay, so let's check your answer. If you got $18.19, that was the correct answer. If you did not, go back and check your work and see where you either made an error in calculation or where you might have been confused about setting up the problem. So when we change the amount used for the variable, the overall value changes. All right, we're going to stop right there and you can click on the next video to continue.